Welcome to another episode of Practice Help here on Geometry with Mr. H. We are dealing with lesson 1.17. Okay, here we're dealing with rigid transformations. Okay, and yeah, so rigid transformations, as you know, are transformations that happen, and the size and shape of our original is preserved. So the resulting image, right, the shape that we get after we've done stuff to it, moved it around, flipped it, spun it, or whatever, is still the same size and it's still the same shape. It might be in a different location, it might be facing a different direction, but if you cut the two pieces out, you could put them together and they would match up perfectly, okay? Because they're still going to be congruent to each other. That's what rigid transformations is all about. All right, quadrilateral ABCD. All right, there it is, ABCD, right, is congruent to quadrilateral A prime, B prime, C prime, D prime. That's this one, A prime, B prime, C prime, D prime, right? They're congruent. That means that they are the same size and the same shape, right? Okay. Describe a sequence of rigid motions or rigid transformations that takes A to A prime, B to B prime, C to C prime, and D to D prime. How am I going to get this shape, which is called a trapezoid? It's a specific type of quadrilateral where you have two sides that are parallel to each other and no other ones, okay? So just two. Some countries, they're called trapezium, but I think mostly in the US we call them trapezoids. All right, so here we go. Yeah, you just have to answer this. How would you get this shape to land perfectly on this one? You have to be specific, right? If you're going to tell me that there's a rotation involved, you got to give me the three pieces of information that I need, right? I need to know what's the center of rotation? How many degrees are you rotating it? What direction? Is it clockwise or counterclockwise? If you're going to say that it gets reflected, you better tell me exactly what that line of reflection is going to be. And if you're going to translate it, you got to give me the vector, the directed line segment, right? 2 points, right? From X to Y, wherever that is, right? Okay. Obviously, there's no point X on this or point Y, but you get the idea. All right. Pause the video and answer the question. Task 14. Select all transformations that must take any point A to any point B. Okay. So, which of these statements would definitely, absolutely, 100% of the time take point A and get it to land on point B? That's the question. Okay? So you're just going to have to look at all of these and figure it out, right? Check each one. Read the first one. Does that work? Is that always true? If it is, check it off. If not, don't check it and move to the next one, right? Okay? You got to go through all of them, all right? And think through it. Task 15. Triangle ABC is congruent to triangle A prime, B prime, C prime. Okay, so these two triangles are identical to each other. Describe a sequence of rigid motions, rigid transformations, that takes A to A prime, B to B prime, and C to C prime. Okay, same deal here. Same sort of thing as up here, right? You're going to be specific in your descriptions. How do I get this blue triangle to land perfectly on the green triangle? How can I do that? And again, you have to be specific, right? Every rotation includes the three key parts: the center of rotation, the number of degrees, or the angle that you're choosing to rotate it by, okay? If you have an angle, right, we talked about the ideal, or I should say the easiest way to do this is oftentimes match up 2 points using a translation, then rotate using the matched up points as your center of rotation. And now you have an angle because you're going to match up another two set of points. And then if necessary, you're going to reflect, okay? Reflecting is always going to be your last option, okay? All right, that's what happens right here, right? So you just have to go through that description up here. Task 16. A triangle has rotation symmetry that can take any of its vertices to any of its other vertices. Now, vertices is the plural of vertex and is another word for corner. Okay, so a triangle has rotation symmetry, meaning you can start to spin it and you don't have to go 360 degrees all the way around before it looks exactly the same in the same way as it did when it started. Okay. Select all conclusions that we can reach from this given information. Okay, so they gave us a bunch of information up here. All right, think about what this says and how I just described it. Right, and then select all of these that must be true given this stuff that I've highlighted. Okay. All right, next problem. Task 17. Here's another one of those amazingly, shockingly beautiful flowers / 4-leaf clovers. All right. Select all the angles of rotation that produce symmetry for this flower. Okay, so as I spin this, right, if I go through these spinning moves, right, if I start here and I rotate at 30 degrees, does that end up looking just the same or has it changed? If I rotate it 45 degrees from this original position, will it look the same or will it look different? If I, basically you just got to answer that for each one of these, okay? All right, task 18. A right triangle has a line of symmetry. Okay, so a right triangle, as we know, is a triangle that has a right angle in it. All right, awesome. Okay, now, so we imagine this triangle, and we're told that it has a line of symmetry, right? A line that if you use it as a mirror, it will reflect across that onto itself. Select all the conclusions that must be true. Which of these statements must be true of any right triangle that has a line of symmetry, right? Any triangle that we can come up with that's a right triangle that has a line of symmetry, which of these must be true for that triangle? All right, here we go. You'll notice that some of these questions are similar to lessons in the past. It's because you're being forced to look at them slightly differently than you did before. All right, quadrilateral BADC. Right, there it is, BADC. AB equals AD, so this line segment and this line segment are the same length, and BC equals DC, BC equals DC, so that means that this is a kite. Yes, it's a kite shape. All right, great. Line AC is a line of symmetry for this quadrilateral. Okay, so that means that this line from A to C is a line of symmetry. It looks like I got that a little bit off there. There we go. All right, so line AC is a line of symmetry for this quadrilateral. Based on this line of symmetry, explain why angles ACB and ACD have the same measure. Okay, ACB, and ACD, why do they have the same measure? Okay, explain here. Pause the video and answer the question. Task 21. Which of these constructions would construct a line of reflection that takes point A to point B? All right, so we're not looking at this diagram. That's not what it's about, okay? It's also not about that diagram up there, okay? So all we have is 2 points, A and B, in the middle of a blank page, okay? Which of these things would create a situation where we have a line of reflection that would cause point A to land on point B? Check out each statement, figure out which ones are true, and put checks by those. All right, next one. All right, so this is all for task 22. This is our original diagram. Whoops. This is our original diagram, okay? And what we're looking at is we need to match these descriptions down here with what happens to our original triangle. And what you're going to do is you're going to grab onto these things and you're going to move them around until they match with either 1, 2, 3, or 4. Okay? And that's what you got to do, right? There's your original. And if you rotate it 300 degrees clockwise around O, there's O, 300 degrees clockwise. Clockwise is this way, 300 degrees. Which one of these shapes will it look like? And then drag the box over to the one that it looks like. Okay? And that's it.